I don't know what is the time there in different parts of the world, but I will say good morning. Okay, so we have recently done research in Kuwait College of Science and Technology. Basically, I would like to say that I'm Murad Khan, working as assistant professor in the Kuwait College of Science and Technology, one of the leading university in Kuwait. And so we have done one of research in our university, and that research is to protect the IoT devices from different type of malicious attack in a home environment. And I'm going to present on behalf of my co-authors, Dr. Khalid, Dr. Basil, and Dr. Chibli. So let me go to the contents that I'm going to talk about today. I will talk about the introduction, and I will introduce the the botnet in the IoT environment, and then I will talk about the techniques that have recently developed to how to detect the botnet in IoT environments, and then I will be discussing different problem statements that why we are actually going to do this research, this type of research, and then I will talk about the proposed idea and something related to the testbed environment, and then I will conclude my presentation. So I will like to introduce that what is actually Internet of Things. As you know, if there is a physical object connected to the internet, we call that Internet of Things, because the thing is actually available on the internet, and somebody can access that thing with the help of an internet connectivity. And according to one of the recent research, which is done by Juniper researchers, so in one of the leading firm in the world, which is like producing different networking devices, they said that around 50 billion devices will be connected by the end of 2022. And we are somewhere near to those connected devices. One of the reasons behind this is that you know that computing is becoming more they are actually we are minimizing the size of the chips and those things. So that's why smaller devices could be attached to the network. As you know that we can use these smaller devices in different environments, such as like industries and other places in the home environment and so on. And since 2010, the number of those devices are actually increasing in number, and we are actually they are actually helpful a lot in different ways. You know that Google is working on Google Home and so on, and the Qualcomm is working on similarly smart home environment. So many different companies are actually working on such environment, and you know the internet thing is actually they are presenting a unique setup like security challenges. One of the challenge in this regard is actually the botnet attacks are the how we can enslave an IoT device in a home. So let me start with one of them, with the very basic one, which is what we call a bot. So what is actually a bot? It's actually a malware that is performing something autonomously and automatically on a compromised machine. So let's suppose an attacker is able to install a software, a malicious software, a malicious code into an IoT device, and then using that IoT device for their own purposes. This means that somebody else is actually controlling this sort of device, and so that's one of the reasons we will call this a bot, because somebody else is actually connecting to it and automatically somebody else is automatically controlling it. And if there are many numbers of bot are connected to each other, to a network, and they form a network, and then we can use these boards for one particular purpose. For instance, like we can send distributed denial of service attack on a particular victim server. So there is a possibility the victim server will not respond to the legitimate user and so on. So we can call this a botnet. And the botnet is further divided into two parts. One we call centralized botnet, where the bot master, or the one who is actually controlling the bot, is connected to the server, and that server is further connected to the rest of the IoT devices. We call that a centralized approach. And the distributed approach, where the bot master is, or the person who is connected to the bots, directly connected to those IoT devices, we will call that a distributed botnet. And both of them have challenges available, and both of them have advantages and disadvantages for the bot master, and for the person who is actually, or the attacker who is using these type of devices. Now, before going to talk about the rest of the thing, I would like to explain what is actually an IoT botnet, like how an IoT botnet works and why we are actually dealing with this, because it's one of the most important thing for us to see into it and to handle it and to perform some research on it. Because you know that in 2016 there was a botnet attack happens, which is we call Mirai botnet, and those Mirai botnets, you know, they produces a huge amount of you know, distributed denial of service attack on different victim servers, and they get it down for a long time. So that's why it's important to talk about the IoT botnet. Now, how it's working, how these botnets are working in an IoT environment, the very first thing that the attacker is going to perform is called the scanning. It scans the available ports, all the available open ports, and check if there is any available port available. Then the second phase is that the bot master inject a malware into that particular IoT devices. And we know that the IoT devices are sometimes weakly configured with the and many people think that why I can, if there is suppose a television or refrigerator in a home environment connected to a home network, why I want to set a password on it and set a username and password on it so I can protect it. So nobody care about these type of things unless suppose we have a video camera attached to the home network. So there is a possibility we have some weakly configured IoT devices, and the attacker will be able to find the bot by scanning the available ports. So they inject the malware, and once they able to inject the malware will automatically run in the bot, in the device, and once it runs inside into an infected device, the device will become an infected device, and it will start making a connection with the rest of the available IoT devices. So it will automatically start connection, and it will start downloading the malware to the rest of the IoT devices. And finally, the bot master will be able to perform some sort of like sending some malicious command to that particular devices and to perform some particular task. So there are different type of we can say that purposes for a bot master. For instance, that they can use it for a phishing sort of service, they can use it for device breaking, they can use it for denial of service attack, and for spamming and so on. So this is actually how this happens. And finally, the botnet, the bot master is actually maintaining and upgrading those type of things in order to use it in the future. Now, let me talk about the technique that we have so far available in order to detect the botnets available in the network. So one of the very basic technique, or we can say the traditional approach, is actually the host-based technique. Now, the host-based is further divided into client-based and network-based. But in the case of host-based, what we can do that we can go to a computer and or to the IoT devices, and we can perform some sort of detection and to check that whether this is a bot or this is not a bot. In the case of client based, we can perform the sort of detection on individual IoT devices. In the case of network based, we can perform it on the traffic that is generated by this type of device, the IoT device. The client base is further divided into static and the dynamic. There are many different type of things that are available for this purpose, but we can broadly divide it into the client base and network base. And if we want to perform the detection, there are another technique used, which is a very simple technique and very fast technique. We call it a signature based technique. So we can have a signature of the available patrons, okay, of the malicious pattern, and we compare the patterns that we can get it from the IoT devices. We can compare it with the available to the templates, and we see that if the activity is malicious or those identified in the traffic we generated from the IoT devices, we can say that there is some sort of botnet activities going on from the device or not. And then we have the anomaly-based detection. In the case of anomaly-based detection, what we actually do, we classify the network traffic into anomaly and benign, and then we see that let's suppose in some particular time, let's suppose there is an IoT device, suppose a refrigerator connected to a server, and it is sending a huge amount of traffic. So we think that this is sort of anomaly and we can track it down. And similarly, the most recent technique we have based on machine learning, or we can say deep learning, where we can classify the traffic into normal and abnormal based on some sort of feature mapping and those type of technique like feature extraction, and the mapping technique we can apply, and we can see that which one is actually normal or abnormal. And some research we found on the Google Scholar regarding the use of reinforcement learning detection-based technique. So it can actually, the detection technique can learn from the environment, and once it learns and it understands that there is a particular sort of activity happening, it perform a particular action in that. Per that action, they get a reward and so on. So we know that this is how the reinforcement learning technique works. But nowadays, we found in the literature in like from last 3 to 4 years, we have seen many different techniques based on reinforcement learning. Now, if we have a lot of these things available in the internet, so one of the idea is here is the why we are actually doing this research for IoT devices, or how we can say that IoT devices could be protected in an environment. One of the problem with the IoT devices is that they have limited memory and processing power. So for instance, if you install the deep learning models on such a small device, there is a possibility that we cannot get what actually want because of the limited memory and processing power. And those devices are sometimes weakly configured, because many times nobody thinks, even if you are there and there are some people there in their home, there is something connected to the internet, they will never care about setting a username and password for those type of devices. And we are not going to close the open ports that's available in those devices. And the solution that currently available is expensive. And one of the reasons is that many devices are connected to the internet. So every device has a different configuration. And this is one of the reasons that it's expensive. And the maintenance is also poor, because we know that it's sometimes inappropriate. We know that with the passage of time, there are many botnet attacks we can detect. So maintaining all those things with techniques such as signature based or deep learning based or reinforcement learning based is requiring a lot of time. And the other thing is that non-interactive or minimal interactive user interface. For instance, we cannot connect to our refrigerator that is connected to the internet by some sort of computer or some sort of interface or user interface. So this is also one of the problems. If we have something similar thing, then there's a possibility that we can connect to that IoT devices. And at the end of this problem statement, I would like to say something that let's suppose someday the police will come to your doorstep and they will say that this is a sort of funny, but they will say that your refrigerator or your television hacked a bank. So this will be a really interesting scenario. So in order to tackle with those type of situation, why not we can start with producing something, some sort of detection mechanism that can detect with some sort of lightweight security model, can detect the botnet in the IoT environment. So we have a proposed idea for that. We actually divide this into two phases. In the first phase, our thinking is to set up a botnet attack phase. So what we do, we scan the available IoT devices, and then we inject the malicious code. If we found some sort of open port in any of the IoT device, we download a malicious code into it, and that malicious code will automatically run on the IoT device. And after that, the malicious code will be starting. The device will become a bot, and the bot will download the malicious code from the server, which we call command and control server, and then this will start distributing, and at the end, all the IoT devices will be infected. This is what we have done in our lab, and we already infect 20 of the IoT devices that is connected to the network, and we infect them all with the malicious code. Okay, for this purpose, we didn't actually build a startup server to download the malicious code, but what we do, we say that this is one of the IoT devices. We directly connect to the computer and we download the malicious code into it. So this is what we have done so far. And the second phase is the detection phase. Now for the detection phase, we actually design a layering architecture. So we put different layers of security. Now, the very first layer is actually called the filtration phase. We filter the network, the traffic that is generated from the IoT devices based on blacklist and whitelist. In the case of blacklist, we blacklist all the IoT, all the IP addresses that were previously involved in sort of malicious activity. We don't know, but for this purpose, we just generated some sort of random IoT devices. That some of the IoT devices is connected to the internet. We say that those IoT devices will be blacklisted and those are whitelisted. And after some time, we also set some sort of algorithm that after some time, like after 24 hours, if the same IP address is not involved in any sort of malicious activity, we remove it and we put it in a gray list. So we also have a gray list as well. And we will monitor the activity of the gray list for the rest of the 24 hours. And after that, we put it in the white list if there is no such activity available from that particular device. Second thing is actually the detection phase. The detection layer we call the detection layer, where we thresh we set a threshold on the traffic that is generated by the IoT devices. So this threshold is actually on the traffic that's generated. Suppose if a particular IoT device in a particular time generating 50 or more than 50 number of packets, we think that this is some sort of malicious activity, and we will block the connection to that IoT devices. And after that, we have another layer of security, which is called the screening phase. In screening phase, we generated a profile for the IoT devices. So each device is actually provided with a particular profile. For instance, a camera in a particular time will send a large amount of traffic to a server. So that is an abnormal activity. But we will say if the camera is sending this huge amount of traffic from, let's suppose, 8 to 9 in the evening, so we will think that, okay, this time we know that the profile of this IoT device could send the huge amount of traffic at that particular time. And similarly, let's suppose the refrigerator will be continuously sending data to the server, but that data will not exceed that particular limit. So we can say that this is the profile for the refrigerator, and so on. And the option of scalability should be there, because if we added a new IoT device, then there is a possibility that it could be blacklisted or whitelisted. So for that purpose, we also have the scalability option. And another important thing, let's suppose a router that is connected to the IoT devices, okay, and it perform, and we have all these three different layers of security available in it, and this IoT, this IoT router knows that this home router knows that knows a lot of information about the malicious activities. So this router can share these information with the rest of the router that is available. So for this purpose, we actually connected two different routers. One router is connected with the 20 IoT devices, another was connected with the 10 IoT devices. Both of them are actually managing different IoT network, and they were actually sending information to each other. So suppose one of them is gaining some sort of knowledge about the malicious activity in one home network, it can share the information with another one. So this type of this will help us to reduce the knowledge or the experience of the home for the rest of the home routers, and it will also reduce the time of performing some sort of computation for the home routers, for the rest of the home routers. Okay, this is the implementation scenario. We already have these servers available in our lab. We perform we already code these server with the required information, and after that, if you can see on top of the server layer, and then they are connected by LAN with the edge router. So as I discussed, we have two different edge router, and those are connected with each other, and they are also connected with the with an environment. So here we have the reflection of an environment where a Raspberry Pi is actually connected to the home appliances. Okay, so this is the start of the network, and this is what we have done so far. And we are already receiving some information where we install the Wireshark, and we are looking into the information whether the code that we have performed here on the home edge router that's working fine or not. So we already have some sort of results available, but we will publish those results in our upcoming in future. This is what the So actually, basically, from this research, we want to design a lightweight security solution for home network instead of complex structures such as based on deep learning and those, because it will require a huge amount of time for the and maintenance, and those things will be becoming difficult for the home users. So that's why it's good to have a lightweight security solution, and this is how our system can perform a DAS attack, and after that we can perform the identification of the malicious traffic using the detection, filtration, and screening. And the test-based implementation is working on the way. We are actually working on it, and I hope in future it will be ready for performing real world testing. So thank you so much, and this is all from my side. If you have any question, please